thing that's different, vertical transformations always occur outside of the parentheses. And horizontal always occur inside. The second thing I want you to write down is vertical transformations happen to the whole function. And horizontal transformations only happen to x. And it will make more sense as we start to go through, but that's something that you can have on top of that page, and those are the two things that are really important to remember as you're applying transformations. So, we are going to use for all of our vertical transformations, we are going to use the line f of x equals 2x plus 3. So on these first graphs, graph in your pencil, your original color, f of x equals 2x plus 3. So graph that on both of those. This little table is just a kind of a cheat sheet for how the function rules are applied. If you're shifting up or down, right, because if we're talking about vertical, if I'm going up and down, is that a vertical change? If I'm going left and right, is that a vertical change? No, that's a horizontal change. So going up and down, you are adding or subtracting values from the end of your function. If you are reflecting over the x-axis, because if I'm flipping over x, that's vertical. If I flip over y, that's horizontal. You're going to multiply by a negative. And then vertically stretching and compressing is when the slope changes, but we'll talk about that on the next page, okay? So let's just talk about up and down. We know based on yesterday that if I took f of x equals 2x plus 3 and I shifted it up 2 units, what's my new function? 2x plus 5. Everybody agree with that? That would be my new function. Go ahead and write it. Yeah, as I write, you're right. You guys know that based on yesterday. If I was going to take my original function 2x plus 3 and I was going to shift it down 5 units, based on what we talked about yesterday, what would my new function be? Equals 2x minus 2. But that's just after the transformation has been applied. We're going to address the rule. So the rule for shifting up and down is that you take the f of x, or your original function, and you add a value of k. So if I'm shifting up 2 units, my k value is 2. The value of what k is not the important part. The important part is writing the rule. So here's where our rule is going to be. What you guys did was we took f of x and we added 2. So this is my function notation rule. So on a quiz or a test, if I said write the rule for shifting up 2 units, that would be your answer, f of x plus 2. Because this rule can be applied to any function. So f of x is just whatever function you're dealing with. I can plug in any function. If I gave every single person in this room a different function, you guys could all apply the same rule using that. Okay? So this is how it's applied. What is my original function? 2x plus 3. My original function is 2x plus 3, and then my rule says go ahead and add 2 to that. And that's where the 2x plus 5 comes from. So yes, I got to the same place, but you guys need to know the rule and how it's applied. Okay? So let's graph the new one. 2x plus 5. Your new color. And we can check, my line shifted up, so everything checked out nicely. Okay, if I'm shifting down 5 units, the rule is going to look similar. What's my K value? -5, and my function rule would be -5. And the application, replace f of x with your function, which was 2x plus 3, and then the -5 gets tacked on, which is where 2x minus 2 comes from. So I get the same thing, but that is the rule and the application. So go ahead and graph your 2x minus 2 on that graph. Those are the easy ones. Now flip the page. And we're still using f of x equals 2x plus 3. Go ahead and graph it on these 3 graphs with your pencil, your original color. Okay. You're reflecting over the x-axis. You are flipping over the x-axis. And this point is going to be the same for both lines. Okay, because this line is going to flip, and that's your point of reflection. So it flips on that point as if it's an axis. Because it's flipping over the x-axis, so reflecting. Your rule is that your function, f of x, is multiplied by -1. So -1 times f of x. Or you will just see it as negative f of x. Because that is the same thing, right? Everybody agrees with that? Yeah. Okay. You're not going to see it as -1 times f of x, but just so you know that that's the same thing, it's in your notes. So again, what is your original function? 2x plus 3, and I'm going to take the entire function and multiply it by -1. So what is my new function going to be? -2x minus 3. So not only did the slope invert, but so did my y-intercept. So when I graph it, it should go through that point that they share on the x-axis. So down 1, 2, 3, -2. Did it work? If I'm vertically stretching by 3, again, they're going to share that point. If I take the line, like a piece of string, I'll just use a pen. Okay. So if I take my line and I stretch it vertically, what do you associate with something stretching? Not math.
Getting taller.
Getting taller. Pulling something. You stretch something, you're pulling it, right? So if I'm vertically pulling something, I'm pulling from the top to the bottom, and I'm stretching that line eventually into a complete vertical line. Okay? So a vertical stretch is going to get that line closer to a vertical line. It's going to make it steeper. So if my vertical stretch is by 3, my A value is 3, and the fact that it's A and the other one's K, none of that really makes a difference as far as like what you're going to be asked about. I'm never going to ask you what the A value is, okay? But the rule I will ask you, because what you're doing is you're taking your entire function and you're multiplying it by 3. And it would be written as 3f of x, but just for your note, it's 3 times f of x. You're taking the entire function, and what are you doing to it? Multiplying it by 3. So that original function that you had of 2x plus 3 is now getting multiplied, yes, and it is going to become 6x plus 9. So not only did the slope change, but so did the y-intercept, but they should still share this point on the x-axis. So I'm going through 9, 4, 5, 6, 7, 8, 9. Wait. 1, 2, 3, 4, 5, 6. My line got steeper, and it still shared that point. What the point is, doesn't matter, but
So it's positive 6 over negative. It's just like
positive 6 over positive 1. Because remember yesterday when we were talking about reflection, the slope change signs. Well, if you change the sign, what are you doing to it? Multiplying by negative 1.
So what are you doing? So negative 1. Is it down 6?
No, yeah, down 6.
Down 6 left. 1. Okay. Vertically compressing. When you compress something, you're pushing it. So if I take the line and I vertically, so I'm at top and bottom, compress, my line is getting closer to a horizontal line, so I am flattening that line. The process itself is still the same, because in order to flatten this, I'm going to multiply the whole thing by 1/4. The only thing that's changed here is that the value I'm multiplying by is no longer larger than 1, it's now smaller than 1 to create that flattening. So my A value is 1/4. Any guesses at what my function notation would be?
1/4.
1/4 f of x. So you take your original function of 2x plus 3, and you're going to multiply the whole thing by 1/4, which is going to give us something very fun to graph. F of x equals 1/2 x plus 3/4. So 3/4 is about here. Up 1/2. Line got flatter. Where'd the 2 lines cross? Same point at the x-axis.
So you're gonna compress and do the compress that fraction.
Yes. Vertically compressing. You're always multiplying. Okay,
The x-axis, if you go down one, how is it?
down 1 over 2. That point is not a point that we actually found, it's just where they cross. Okay, let's get to horizontal because I'm going to run out of time. What time are we at? 37. Okay. We still have to do all of the horizontal. So, now, horizontal rules, we're shifting to a different section now. Remember at the beginning I told y'all to write vertical is outside the parentheses, it happens to the whole function. Horizontal, everything happens inside and it only happens to x. Okay, so these are going to be shifts left and right. We're going to reflect over the y-axis and then horizontally compress and horizontally stretch. Okay, so what I want you to do is graph 3x minus 1 with our new function on these graphs. To be graphed, I'm going to hold my ruler up to the board, and I want you guys to think about what's happening really quick. If I take this line and I want to shift it left 4 units, so I'm going left, 1, 2, 3, 4. If I think about my equation, what parts of my equation have changed? The slope has not changed at all. The y-intercept. But what happened to the y-intercept? It shifted up. So in order to go left, I have to shift up. So the rule is going to seem really strange because we associate left not with addition, but with subtraction, but in reality, our k value is 4, and my function notation rule is f of x plus 4, because I have to increase the y-intercept to move that line left. And so if I put minus 4, I'm not going left anymore, I'm going right. Make sense? Okay, so f of x plus 4. You see how it's inside the parentheses now and not outside? Yes. Okay. Now, what was your original function? 3x minus 1. I'm going to write it really small because the application is different. X got replaced with x plus 4. But the remainder of the equation comes down around it. It's just x because I replaced the x. I didn't do anything to the whole function. I'm adding 4 to x, not to f of x. So if I do that, I have to distribute and combine like terms. So I get 3x plus 12 minus 1. So my new function is 3x plus 11. Did my y-intercept increase? Yes, which is what we established at the beginning. I need my y-intercept to go up in order to go left. So if I graph 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What is that?
It's right up there. Yeah.
Okay. I hope it works. 1, 2, 3. Now, when you look, these 2 points are 1, 2, 3, 4 units apart. But the only way to do that is to change your y-intercept, right? That's why it works, because you just applied it to the x. It's in the distribution of the slope, so the ratio stays the same. Okay, so if moving left is addition, moving right should be subtraction. So if I'm going to the right 2 units, minus 2, because look, if I want to go to the right 2, what's happening to my y-intercept? It's going down. So my k value is now -2, and I've got f of x minus 2. So in your function, 3x minus 1, I'm at 3x minus 1? Yes. I'm going to replace, you can set on my back counter. Thank you. I'm going to replace my x with what? X minus 2. And then where does the 3 and the -1 go? Around. Distribute 3x minus 6 minus 1. So f of x equals 3x minus 7.
So if you're going to the right, you subtract, and you go to the left.
Correct. And now my points are
Why is it y-intercept on? Oh, yeah, negative.
taken apart. Okay, y'all ready to talk about some more compressions and reflections and stretches and all that? The last three. Last three. Okay, graph on each one of these 3x minus 1. I know. No. Graph it. You guys probably need practice graph anyways. If I'm reflecting over the y-axis, I'm flipping my line across that y-axis, which means the point that they share is going to be that y-intercept. So if you're checking your work, if it's horizontal, they should share the y-axis, not the x. So my function notation, since it's inside parentheses, would be f of -x. F of -x. So when you're applying (3x minus 1), what am I going to change to -x? Just the x. So this becomes -x, and the rest of the equation goes around it. So now you still need to do some simplification there. What's my new function? -3x minus 1. Okay, if I horizontally compress, I'm not pushing from the top and the bottom anymore since it's horizontal. I'm pushing from the side. If I push from the sides, what's happening to my line? Steeper. It's getting steeper, right? So I'm going to have a value that's larger than 1 because that's going to make my line steeper. My A value is 2. And instead of multiplying f of x by 2, all I'm multiplying by 2 is x. So if it was a horizontal compression by 1/2, is that 1/3? By 1/3, what would my function notation rule would that be? F of 1/3 x. So where you see x in your function, so 3x minus 1, what am I going to replace it with? 2x for this one, and 1/3 x for the last one.
So is the A the last one out there?
Yes. Okay, so now let's rewrite our functions. So I'm going to pass out your test. I don't have that much. So 3 times 2x minus 1, what did that end up giving me? 6x minus 1. 3 times 1/3 x minus 1, what did that give me? Equals x minus 1. So when I graph them, where will they cross? The y-intercept. So you see how they're different? The x, when you did any vertical transformations that weren't shifting, they all shared that x point. These ones are going to share. Hold on. Y'all want me to tell you your homework? Okay. Your homework is the last page of that packet. Use the given function to describe the listed, I'll wait on you. The listed transformation. Then like y'all are all packing up and nobody's doing what I'm saying. So if they're gonna have questions and they come in tomorrow and tell me they didn't understand what they were supposed to be doing. So stop what you're doing and listen. Then write the equation of the transform function. So all of these are rules, and you have to use the letter to find out which one you have to apply it to. So describe the transformation, apply the transformation. Okay? So it's a multi-step for each one of these. This is due tomorrow.